Welcome to this video. In this video, we're going to talk about probability. And probability is one of the easiest math computation, depending on where you stand, because normally it gives you it helps an individual with the possibility of thinking and also making some choices. So now we're going to look at the probability, and first we're going to look at the probability of tossing a coin. So this is the assumption here is going to be that it's a fair coin, and that we are going to toss it twice and then see what's the probability of getting a tail in both tosses. That when you toss the first time, you got a tail, and the second time you also got tail. So let's look at this. So the first thing is we are going to say, so here we have the okay, so now I think my pen is not picking. So I'm trying to look for some rice. So this is going to be the first toss, where we're going to say we're going to expect a head and also a tail. So normally when you toss a coin, you have the 50% probability of getting, either the tail or either the head or the tail. So in this case, we're going to say here we have the 1/2 probability of getting. So that's the chance of getting either tail or head. Now the first toss, so when we do the first toss, we have like I said here, we have the probability half or 50% chance, or half chance of getting a head, half chance of getting a tail. Now if we do the second toss, so it's the same. We're going to have here half chance of getting head and tail. So I just want to change here so that we have here head and tail. Here we have head and the tail. So it's always a good practice to talk about the possible outcome, the outcomes that we expect. In this case, we know that we're going to have head. So one outcome is going to be like we have both, every tossing we have head and head. Another one is that we have a head and a tail. So head and a tail. Another one is going to be have a tail and a head. And then another chance is that we have a tail and a tail. So all these chances, so in this case, because only 2 times tossing, we expect up to 4 results. That means either we are going to get a tail and a tail, a tail and a head, head and a tail, or both are going to be heads. So in this case, now they're asking, what's the probability of getting a tail in both tosses? So that means then we will just want to look at where every toss that we tossed, there was only a tail. So that means this is our main focus. What's the probability that when we did the first tossing, we got a half, we got a tail, and another one, we also got a tail in both tosses. So basically what we're going to do here to get that answer is going to be a first tail. So that's going to be a half multiplied by a half. So that's going to be a quarter. So the possibility, the chance of us getting 2 tails after 2 tosses is a quarter. So that's how you do probability. And sometimes they would ask you, what is the probability of getting a tail and a head? So that's going to be, a tail and a head. So here we have a tail and a head 2 times. So let's look at this. So here we have a tail and a head. Here we have a tail and a head. In that case, what you'll do is you're going to have, what's the probability of doing a head and a tail? So head and a tail is also the same, a quarter. And then plus, then also we're going to look at another, this one here, also tail and the head. So tail and the head is also a quarter, because you remember we multiply a half times a half to give you a quarter. So then we're going to have here quarter. So that's just like this process being shortened. So then what you're going to do, you're going to just basically have LCM is going to be 4, 1 plus 1. So that's going to give us 2/4, which is equivalent to 1/2. With the possibility of getting two, at least one head and at least one tail is going to be a half. So that's how you do the, that's how you work with probability. So that is what I wanted to show you. I'm going to look to the next questions where we're going to talk about probability with replacement and probability without replacement. So in these questions, we're going to talk about here. So a bag containing, so there's a bag. Okay. So assuming there's this bag here, I don't know, with a zipper or something like that, and it contained 8 black balls and 5 white balls. If 2 balls are drawn from the bag one at a time, one after another, so I think here one at a time, so that means they don't take it once. Now then draw the probability that you get different colors. So that's, sorry for that. So what's the probability that we have different colors? Especially that we have here either white and black. So let's see. So this is how we want to handle this. So let's go to the question. So the focus here is going to be we're going to take the first attempt without replacement. So without replacement, that means like we're going to do the first drawing. So like you see, all for us, we have to get the total number of the of balls now in the bag. That's going to be 8 plus 5, which is going to be 12. Okay. So here, the main goal is like the first drawing, you're going to expect either that we have a black or a white one. So that's the first drawing. And if we have the black one, then it's going to, the probability of getting a black will be 8/12. The probability of getting a white will be 5/12. Now, remember, when we're going to say without replacement, now there's no replacement. So that means we're going to have one less. So in this case, we're going to have here 7. Probability of carrying this one is going to be 7/11. And therefore, this probability here is going to be 4/11. So then we're going to have the probability of getting black one is going to be 7/11. The probability of getting white one is going to be 4/11. So that's the probability. Then the same here, the probability of now getting a black one and the white one is going to change. So here we're going to have 4/11, and the probability of getting a white one is going to be 7. Sorry. So I messed that one a little bit. So let's say, so the probability of getting this is going to be so here we're going to have probability of getting here this is going to be 7/11, and this is going to be 4/11. So that the total probability here should be 1. Okay, so after having this, now we want to check on like what's our outcome. So if we say like, if there is going to be all black, so we're going to have black and black. And then otherwise we have black and white. or we have black, white and black, or we have white and white. Now, they want us to find the probability of drawing different colors at the time. So that's going to be this one and this one. So basically, we're going to look at the probability of drawing black and white, and then add the probability of adding white and black. So now, black and white is going to be 8/12 multiplied by 4/11. Okay, so that is this one here, multiplied by this one. So that plus probability of white, okay, and black. So that's going to be 5/12 plus 7/11. So that's going to be what we work with. So we know that 4 goes here 1, 4 goes here 3 times. So we are going to have here 8/33. We're going to have here 8/33. Plus, then here also we're going to look at 35 times 1/32, 132. So here we have 35/132. Sorry, so we're going to look for LCM here, a number that 33 goes into, and also 32. So 132 is still the LCM. 132 because 33 goes into 132 4 times. So 4 times 8 will give you 32. Plus 32 goes here once. Times that one is going to be 35. So here we have now 67/132. So the probability will be 0.5075, which, yeah, if you want to put it on a half, if you want to leave it here, should be like a half, but also we just want to say the probability of getting at least, so here to answer this question, to get at least 2 different colors in every drawings that we do is 0. So wait. So to answer that, the probability of getting at least different colors after drawing will be 0. Yeah, so will be this one here. 0.575. That's the probability of getting at least 2 different colors. So that one is done. Let's look at the one with replacement. So that means so now that one we did without replacement. So now let's look at with replacement. So that means that every time you withdraw, you check the probability, and again, then you return all the balls in the bag, and then again draw again. So in this case, we're going to say, okay, so what's the probability of, you'll see quickly the difference. So probability of getting black and white. So it's 8/12. And here is 5/12. Now, when we go to the other level now, because now we've replaced the second drawing, when we want to draw, the thing is that in this case now again, we're going to get the same probability. So again, the probability of getting black and white and the probability of getting black and white is going to almost be again the same. So here is going to be 8/12, and here is going to be 5 over 12. Again, here is going to be 8 over 12. Here is going to be 5 over 12. So in that case now, if we are going to look at what's the outcome, so our outcome will be like this. So you're going to have here, for us to get different colors, so B and W, so it's going to be the first probability, that's going to be 8 over 12 plus 5 over 12. Plus, so then that's PW, and then also this is going to be probability of, that's going to be WB. So the probability is going to be 5 over 12 plus the, yes. Multiply by, multiply by. It's not plus, it's multiplied by the probability of, so 8 over 12, okay? So it's going to be, and then later, then we're going to add the probability. So all these are multiplied by, okay? So here we're going to get 8 goes here 2 times, 8 goes here, no, 4 goes here to 8, 4 goes here 2 times, 4 goes here 3 times, and 2 goes here once, 2 goes here 6. So here we have 5 over 19. And let's look at this place also. All this, it's about 12. So 4 goes here 2, 4 goes here 3, 2 goes here once, 2 goes here 6. So here's going to be 5 over 19. So if you add the two, you're going to basically get 5 over 19 plus 5 over 19. Since the denominators are the same, so we're going to just have 10 over 19 as the probability of getting two different colors. So that's how you do a probability. I wanted to just share with you how probability is done, and I hope you now learned how these probabilities are done. And I hope that you enjoyed. If you didn't subscribe to our channel, please subscribe so that so that we you support us. Otherwise, have a nice day. Bye-bye.